We're back to learning to code. We are in the next section on freecodecamp.org. This time it's about JavaScript. It's 113 steps for the basic course. It's going to take us definitely longer than an hour. I would expect it to be 2 hours or something. So maybe you don't want to learn it in one session. Watch half an hour, do half an hour yourself, and then come back to it tomorrow for the next half hour and so forth. It's a good introduction that starts at the complete basics, so if you've never used JavaScript, you don't know anything about programming languages, this is a good place to start. At first, we can write comments in JavaScript as well. We know that from HTML and CSS. It looks a little bit different from HTML, but the process is the same, and in the browser, the code editor in this case, you can see that it's now turned green, and when you write the code it has a different color, but you can always outcomment something by adding these two slashes. Let us declare our first variable. These are a couple of new terms, initializing, declaring, stuff like this. You're going to learn it as you go, as this is going to be repeated time and time again. The way to do it is to use var, which is basically a placeholder for the variable type. You can see that up here we can have strings, numbers, Boolean, and afterwards you add the name of your variable. We can store values in it with an equal sign. So in this example we have myvar, and we'll set it to 5. And if we want to add the value 7 or assign the value 7 to a, we can do that just like this. So variable a, and then in the next code line a equals 7. You can also see the first line as the declaration, so where you actually create the variable, and the next is to initialize it, so to assign a value to it. And here it is shown once more. You can also use variables to initialize other variables and give them a value. So if you have variable a and it's 7 and you've got variable b, you can write b equals a, and therefore b will have the same value as a, which is in this case 7. There's a shorter way to write it. So you can just declare the variable var, add your variable name afterwards, in this case a, equals 9. So you've assigned a value to it directly. Therefore we have declared and initialized the variable in the same code line. And usually you want to write it like this as it's shorter. It doesn't just work for numbers. We can, for example, also use strings. So characters, words, simple letters, but you always have to use quotation marks to indicate that it's a string, and you can use single or double quotation in JavaScript. So let us declare a variable, my first name, and we'll set it to the value of Michael, but if we have missed the quotation marks, it doesn't work, we'll have to add them. Let us use my last name for the second variable. It works with the double quotation marks, but we can also use the single quotation marks. But you cannot mix them up, so you can't use a single as the start and a double at the end. It always has to be the same. Let us understand the uninitialized variables. So in the example we've got a couple of them declared, but we haven't assigned any values to them. And now we want to add certain values to them in the first 3 code lines right here. So right after the first comment. If we set the first one to 5, we have right here a equals a plus 1, so a equals 5 plus 1 would be 6. Next one would be b equals 10 plus 5, and we can do that with strings as well. So we have I am a string if we set the initial value right here to I am a. Let me check what we really need here. I run the test, and it wants me to have a final value of 6. Alright, so our final value is not 5 for this. The initial value is 5, so that we have a final value of 6. And the second should be an initial value of 10. Case sensitivity plays a role, so the way you write your variable names, it has an impact on how JavaScript accepts them or uses them. Usually you want to use camel case, so let me show you this for the first example. It would be startly, and then use a capital C, cap, and then a capital V for startly cap var. And only if right here the variable assignment has the same name and it is written the same way, this is going to be the same variable. Otherwise you're going to get a reference error. So make sure that you always write it the same way, and by default use camel case as its best practice. There are certain types of variables. So var, as I said, is more like a placeholder, a general way to declare a variable. But we can also use a let, which is introduced in this section. Let us check this example. We've got James and we've reassigned it to David. And this is what the console.log will write. So we'll get David. This is not going to work if we use let instead of var. So you cannot write let camper equals James and afterwards let camper equals David. This is going to be an error. So you can only declare and initialize a let variable once. What we'll have to do in this course section is to change both to let, as they have different variable names. There's not going to be an error. So we're good here. Let us check the next variable type that we've got, which is a const. So it's for constant variables. And you should use that if you don't want it to get new values. So you declare and initialize it once, and the value of it can't be changed. So here in this example, we've got faithpet. It has the initial value of cats, and you can't just override it with dogs in this case. A const variable is always constant, you could say. In our example, we want to play around with the values that we've got right here. So let us check the second one first, which is the variable fact. We're going to override it in the third code line, so we use a let variable type, because that way we can override it. And we want to change the variable in the first code line as well. And this is supposed to be a const variable. It's not going to change. But we should also rename it. So we use fcc. But if you do it like this, you're going to run into a problem. Just check the example. If you have a constant variable type, it's best practice to use all uppercase. So like this, fcc. And now we're good here. Let's move on to the next task. And this time we are going to add values. So this is what we can also write in JavaScript. These are simple math equations. They use the common operators, so plus, minus, and you can add them as values to variables by doing this. Here's the multiplication sign, which is the star symbol. And you can also divide values by using the slash icon. The plus plus operator is used for incrementation, and incrementation simply means that you're going to add +1 by doing this. So it's just a different way of writing +1. If we add myvar plus plus, it is equal to myvar equals myvar +1. So this is simply what incrementation means. And you can also decrement your variables by using minus minus. So once again, it's a different way of writing it. It's shorter, and the shorter the better, as it saves time and makes your code less confusing. Let us declare a new variable of my decimal, and we'll add, for example, 10.2. This can also be stored in variables. Obviously, all of these math equations, they also work on decimal values. So 2.0 times 2.5 equals 5. This is also possible in JavaScript. Another example with a division. So we're going to change this value to get 2.2. So we need 4.4 divided by 2.0 to get the result that we want. Remainder, this is something that you may not be familiar with. You use the percentage sign for it. And let us go over the example first to clarify what that is. You've got 5 and then a remainder 2. And the result of that would be 1. Because if we divide 5 by 2, this would be 4 divided by 2 and a rest of 1. So this is the way you should understand it. And what that usually does is, if you use a number and it gives you a decimal result, this is going to be rounded down. So 5 divided by 2 is obviously 2.5, but it's going to be rounded down to 2, so the nearest full number, and it's going to give you the rest. Let us go over one final example. So we've got 11 divided by 3, and this would be 3.666. So 9, 3 times 3, plus a rest of 2. You have to use the remainder a couple of times to fully get a feeling for it, but I think the principle is now clear. There's once again a shorter way to write these math equations. So if you have a variable and you want to add a certain number to it, you can write it like this, but you can make it also shorter by just using plus equal and then adding the number. So in this example, my variable has an initial value of 1, and plus equal 5 means that 1 plus 5 would be the new value. And here we'll get over this with 3 examples, and we'll write it shorter. So a equals a plus 12 would be a plus equal 12, b plus equal 9, and c plus equal 7. This is just a shorter way of writing it. So in the case of C, we would have 19, 26 for B, and 15 for A, if we write it like this. Same goes for minus, so not just plus equal, you can also write minus equal, and you will have the same results. So again, a equals a minus 6 is the same as a minus equals 6. So this would be 11 minus 6 equals 5. This would be b with an initial value of 9 minus 15 equals minus 6. C has the initial value of 3, minus 1 would be 2. We can also use the multiplicator, so our star icon, and write it like this in this short form. So for the first one, it would be the initial value of 5, and then times equal 5 would get us 25, and we would get 46 for C. Finally, we can also use our division sign right here and make it shorter. Let us once more go over the initial value. 48 divided by 12 would give us 4. Then we've got 108 divided by 4. That would be, let me think, it should be 27 if I haven't miscalculated that. And the last one would be 3. Sometimes you want to add quotation marks to your strings, but quotation marks are actually used to indicate strings. So you have to find a way to get around that, and in this example it is explained how you can do that. One important principle to understand is that you always have to have pairs, otherwise you're going to get an error. So let us go over this example right here. We want to add that as a string to my str, our variable string. And it's going to give us an error. So why is that? Well, it's because we haven't used these slashes to indicate that our quotation marks up here should be part of our string. Now let me count them. So we've got 4 of them with a slash, that's fine. But you can see right here the first one. It doesn't have a closing double quote. And that's what I mean by always having pairs. It's a good idea to check your code accordingly when you run into errors like me here. So I'll have to add another quotation mark right here at the end. And now you can see down here everything is fine. And we also have our quotation marks inside of the string. We can also use a combination of double and single quotation marks to get around issues here and there. Let us go over a couple of examples that are presented here. Right here, for example, for conversation, we've got the single quotation marks, and inside we've got the double quotation marks. So that won't work. For good str, we've got the single ones on the outside, and here are the double ones, so the next pair. And here we've got, for let's, we need another single quote, and therefore we need a backslash, because if we don't add it, we're going to get an error by our code reader. An additional note here, don't mistake the backslash for the regular slash. Let us get rid of the slashes here, and we will solve this issue with single and double quotation marks. For now we've got a syntax error. On the outside we're fine. We have these double quotation marks, but we want to change them to single ones. So we need an opening and a closing one here. And here we've got two pairs of double quotation marks for the values of the href and the target, and therefore it all works. So once again, it's a good idea to think in pairs and try to find them so that you're on the safe side. We have more uses for this backslash. We can, for example, create new lines with it or add an indentation, something like this. Let us get over the example directly here. I'll paste this. So we want to have the first line, the second line, and the third line. And it all should have line breaks. And the second line also has a backslash. And it also needs an indentation. So how can we achieve that? Let me first write it like this. If you want to display a backslash, you need a double backslash. If you want to have the line break, let us go over it. Where's the line break here? New line, \n. So I'll add it right here. And I also have to add it before second line, but I have to add it before the backslash. So put it right here. Finally, we want to indent it. So we need \t. And it should be added right here after the line break. And this is what we need to create the desired results. Here's another concept. It's a basic concept. It's called concatenation. So you can use the plus sign not just for math equations, you can also use it to add variables, to add strings. So if you want to have a sentence built out of text and variables or multiple text fragments, right here in this example our str, you can use the plus sign to combine them. Let us check the example. So here's our first fragment. This is the start. And then we'll use the plus sign. We use quotation marks and now add this is the end. So if you just write it like this, we don't have a space in between these sentences. So you have to add, for example, one here. And again, we can use, instead of just plus, we can use plus equal and also do that to strings. So in the example, I come first and I come second can be written like this. Let us do this for our example. My str equals, then the first part is the first sentence. It should be our value right here. And now we'll write my str plus equals and then double quotation marks. We need, this is the second sentence. And again, be sure that you have added a space in between these two sentences. So you could put it right here in the initial value, or you could have put it into the second one. Now we're going to use the plus sign to add these values and variables. So in the example, you can see our name is used in between these two text fragments for our string or our str. Let us do this right here. My name is, then there's a spacing, don't forget that. We use plus and then my name, the variable. So I've added my name to it as a value, and then plus and I am well as the next text fragment. And again, there needs to be a spacing right here. after my name. You could have also added the spacing right here in the initial value, and then you could have gotten rid of it right there. You can also append variables to strings. Like in the example, we've got an adjective, awesome, and we'll add it to our str with the plus equal way of writing it, so the short form. Some adjective, let me use great, and we want to add it to my str so that it's put right here. So new code line, my str plus equals some adjective. And there's this little space in between that we need. We can find the length of a string by using .length. So if you have a variable, anything like that, you can add .length and it's going to count the number of characters. So in this case, Alan space Peter would be 10. So this little space in between the two names is counted as one character as well. Keep that in mind. And in the example, we want to count last name. So we need .length and then assign the result to our new variable last name length. We can also access a specific position inside of a string, and we use this bracket notation for it. In this example, first name is Charles, and first name brackets 0 would be the C character right here. One thing to understand is that we always start at 0 with counting when we use these index positions. So it's not 1, 2, 3, 4, 5, it's always 0, 1, 2, 3.5. So if we use that on this example, last name 0, we would get the L letter as the first character. It's important to keep in mind for future steps. String immutability is introduced, so sometimes we want to adjust a string, but that's not always possible. For example, here we'll get an error if we want to replace the B letter with a J, as it's immutable. If we want to change Bob to Job, we need to replace the initial value like so. So let my str equals Bob and then my str equals Job, that would do, but accessing it with the bracket notation, this won't work. Let us check the example and correct the mistake. Well, here we wanted to change Jello World into Hello World, so we need to write it like this to reassign a new value to my str. Obviously, we don't have to start at the index position 0 to access a certain variable, in this example ADA. So we can directly jump to the second position, which has the index of 1. Once again, we'll start with 0, then 1, 2, 3, 4, 5. So A would be 0, D is 1, and A would be 2. Let's check our example. We want to access the third letter, so we need the index position of 2. So L is 0, O is 1, and V would be 2. This is what we are going to assign to the third letter of last name. Let's check the bracket notation once more. And here you have to understand the difference between accessing the index position and using .length. As .length doesn't start at 0 with counting, you will encounter that a couple of times that you have to use -1 to get back one position in the index. So in the example right here, last name, we want to get the last letter of Loveless. So we use .length to find the length, but we have to use -1 as the index starts at 0 and the .length, it already goes up. And the .length would be one position above the last letter in Loveless when it comes to the index. So we'll have to use -1 to get to the E. So in simple terms, we've got LOVELACE, which makes it 8 characters. So our length would be 8, but the index only goes from 0 to 7. Therefore, we need length -1 to get from 8 to 7. We can obviously use not just -1, but for example here -3. So we go the full length for Augusta, and then we need 3 positions back. So we would end right here where the S letter is. Let's do that for the second to last character in the last name string, which is once again Loveless. So we use last name.length, and then we need -2. So in this case, -1 would be the E, -2 would be the C, -3 the A, and so forth. The next task is called word blanks, and we are just using this principle of concatenation in a slightly exaggerated manner. So for every word that we need inside of a sentence, we've got these variables up here, and we want to put it into a new variable, the const word blanks. We want to form a sentence that's somewhat reasonable or that is somewhat valid. So let me just construct a simple one. I want to call it the dog, or let me call it the big dog ran quickly, something like this. And you have to be careful because we need spaces in between, and you also have to add them just like this. So now we have then my adjective big, then a space, my noun, which is dog, so the big dog. We need a space again. Then we'll use my verb. Then yet again, plus quotation marks, add a space, plus my adverb. But it's still not finished. If you go over it, we've got the big dog ran quickly. But what's missing is the punctuation. So we'll add it right here, plus quotation marks, and add it. So this sentence uses all of the variables and it's valid. So now arrays are introduced. So you can store multiple values inside of a variable. This is in the example right here, the sandwich array. It has 3 values, you separate them with a comma, and you have to use these specific brackets to indicate that we're dealing with an array. In the example, we've got the const myArray, brackets are given, and we want to add 2 values. We've got a string value and a number value. You can see for numbers we don't need quotation marks. So it's just like with the regular or the variables that you've already seen. You can also create multi-dimensional arrays, so arrays that are inside of an array. And here you see for teams, the Bulls and the White Sox, they both have a number, and they're both an array in itself, and this array teams has the 2 arrays stored as one. So we'll do the same right here for my array. Let me call it age 23, and here 1985. But don't forget, we need our quotation marks for strings, and we can leave them for the numbers, and then everything's fine. We can access the data within an array, but once again using this index. And it starts at 0. So let's have a look here. The constant array has 50, 60, 70, so 3 values. And if we use console log array with an index of 0, we would print 50. And if we store the array with an index of 1, we would store 60 into the new variable data. Let us select the first value here for my array, and we want to store it into my data. So can we do that? We'll just use these brackets, and the first value is obviously in index 0, so the 50, we need a 0 right here. We can modify data inside of arrays, and we can use basically the same procedure. So in the example, we've got our array with 3 values, and we use our array index 0, which is the 50, and change it to 15 in the next code line. Let us do this with our myArray given in the example. And we want to modify index 0 and change it to a value of 45. Always be careful that you don't leave spaces between the array name and the brackets. What we need here is myArray brackets index of 0, and we'll change it to 45 so that the value 18 is changed to 45, and we're good. How can we access multi-dimensional arrays? Well, we use multiple index brackets. So in the example down here, we've got the sub-array. It uses the array index 3. For the example ARR, this would be right here, the 4th position, so the 3rd index. This would be now stored in sub-array. Next example is nested sub-array. It has 2 brackets, so we use 3 and then 0. So 0, 1, 2, 3, it's this entire block. And then we'll use 0, which would be the first 3 numbers right here, so 10, 11, and 12. Finally, we have the element, and it uses 3 array indexes. So once again, we'll start at 0, then 1, 2, 3, this entire block. The next is a 0, so we are here, 10, 11, 12, and now we use 1, which would be number 11. Again, be careful with spaces between the name and the brackets. Now let's head to our example. What do we need? We want to find the number 8. Therefore we need right here the 2nd index, and afterwards the 1, which is the 2nd index. Are we good? We've got functions that are, you could say, inbuilt into JavaScript. We can just use them to manipulate arrays. In this case, the push function is introduced. We can just add that to the first array, and the number 4 will be added. Push always puts what you want to push to the last position, so to the end of the array. Next example, we've got 2 more words, and they will be added after cat. So in index position 3 and 4, we will have happy and joy. Let's go over the example on the right hand side. We've got my array, and we want to push dog and 3 at the end position. So what we need to do is to write my array dot push And within the parentheses, we'll add what we want to push. Don't forget the brackets. We've got a string of dog and a numerical value of 3. So this would now be added to my array, and it would be right here the third value in the second index position. We can also use a pop function, and this subtracts information from the array, and it's always the last information that's, you could say, eliminated or removed from the array. In the example, we've got 3AR, and we use pop onto it. That would remove the 6, so we would be left with 1 and 4. On the 6, it would have been stored inside of the 1 down variable. So if we print it with console.log, we would get 6 for 1 down and 1,4 for 3AR. Let us go to the right hand side for myArray.pop. And this would remove the last entry, but we want to store it into a new variable, which is called remove from array. And we also have to declare it. We can, for example, make it a var, so a variable, and that should be fine. So this would now store cat and 2. We now have a shift function, which removes the first element of an array. So the pop is for the last one, shift is for the first one. In the example, we've got our array, we'll use shift, and I would remove the Stimson from our array and store it in removed from our array. In the example, myArray.shift, we would take away John 23, and we would be left with dog 3 in the myArray. And don't let us forget to store it in a new variable. So this new variable would now have John 23, and as I've said, the array would be left with dog and 3. Another common function is unshift, and it does the exact opposite of shift. So instead of taking elements away from the beginning of an array, we can use it to place something at the beginning of an array. So it's basically what push does, but for the 0 index instead of the final index. Here's another example for our array. We shift something from it. As we do shift in the first position, it would be Stimson, and then we unshift happy, so the new array would be happy, J, and cat. Let us go over the example on the right hand side, and we want to unshift Paul 35 to our myArray. We've got a shift right here, which is going to take away John and 23. And now I unshift myArray and add the new information. So we need Paul and 35. Our new array would be Paul 35, dog and 3. Now we are going to create content for an array that's given. It's called myList. We want to have at least 5 items. So it's a good idea to just write these brackets and separate them with a comma until we've got 5. We want to have the first element to be a string in every of these elements, so we need our quotation marks. Let me just go over some candy or something. And the second value is a numerical value, so we don't need quotation marks. And this should already be it. So this task was just about creating an array. Now functions are introduced, and you can use functions to execute a certain code. So here in the example we've got a function called function name, and when we call that function, hello world is being printed. So we don't have to write console.log hello world all the time. If we want to do that, we can just call the function. And this is kind of like the advantage of having functions. Sometimes they get very complex. And instead of rewriting the code all the time, you just have to call the function and then you can use it very easily. You always need the keyword function before it, then the function name and the parentheses. These are for the parameters. In the example given, so function name, we don't have parameters that are needed. But in the following steps, I'm pretty sure there is one function where we need it. Inside of the function, we want to have console.log and hi world. Finally, we want to call the function. How can we do that? We just use the name and the parentheses, and we're good. And you can see down here it works. So if I call it 2 times, let me just paste it in line 6, it would be written 2 times. And as I said, sometimes functions get very complex, and it makes it easy for us to use them without having to rewrite all of this complex code. And here we are, here's a function with parameters. In the example, it's called testFun, and it has 2 parameters, and these are passed to the code inside. So if we use parameter 1 and 2 with hello and world, these would be passed to the console.log inside of the function, and therefore it would print hello world. Let us just go over an example for ourselves. We're going to call it function with args. And again, don't forget the keyword function before it. And we want to use it to sum up values. So you can use numerical values as parameters as well. Let me just use placeholders for now. I call it param1 and param2. So for parameter 1 and 2. And we want to print it, so we use the console.log. And afterwards we want to call it. So what we definitely need to do is this, console.log, and then print something. There are often various ways to make the code do what you want it to do. You could, for example, in this case, first up create a new variable, call it sum, and then make it equal parameter 1 plus parameter 2, and then console.log print the sum. So if we now call it and add two values, so we use the name, the parenthesis, and inside of the parenthesis we'll add our values. Let's say 7 and 12. You can see it does what it should. So it uses 7 as parameter 1 and 12 as parameter 2. Then it stores the sum of it inside of the variable sum, which is 19, and it is now used in the console.log to print it. If I change it to 70, it still works. So there's one way to write it, but you can directly cut that out and paste it into the console log, which is shorter, and it still does the same. So as I've said, most often you can write code in many different ways to achieve the result that you need. For most functions you need a return. So you want your function to do something and then return. Let's say the sum or the product of a multiplication, something like this. Here in the example we've got a plus 3. So if we call this function with a parameter, let's say 7, it will use 7 plus 3 and then return 10. And if we store this result, we've got a parameter of 5. 5 plus 3 is 8. Therefore, our new constant answer would have a value of 8. Let's create our own function. We need the function, our parenthesis, and a name. We've got times 5 as a name given. So we want to return a value that's multiplied by 5. Let me call that param1 times 5. And we need param1 as our parameter for the function right here. And if we now call this, and let's say we add 5 to it, it would be 5 times 5, so 25. And we would be good here. Let me store the value inside of results and then print it out so that you can see it at the bottom. So I print the results. And we've got 25 down here printed. Let me change this value to 50 and it will be 250. And you can also use decimals, something like this, and your function works. We aren't even supposed to do that here, but I did it anyway to explain it. You can just delete this code line down here and we're good. There's a concept that you need to understand, which is scope. So it depends on where you declare and initialize your variables. Sometimes you can only use them inside of functions, or sometimes they are global variables. So if you declare them once, you can use them basically everywhere. And in this example we've got let and const, and these are global variables by default in JavaScript. So if I declare my global right here as a let, we could use it inside of functions, we could use it outside of them, they're global. And this is what that concept means. And below our new let variable, we want to add another one, which is oops global. Or we can just put it here inside of the function, set it to 5, and we're good. It's going to become more clear what all of this is about scope when you actually use it, so don't worry too much if you haven't yet fully understood it, but the basic concept should be clear. So global variables can be used everywhere, but there are also variables that you declare inside of functions and they can only be used inside of these functions. Here the local scope is introduced and it makes it a little bit clearer what it all is. So in this case we're going to declare a variable inside of a function, therefore it's a local variable. It's called log and it has the value foo. So if we now call our function and if we try to directly print out the log variable, we'll get different results. In the first case, we use myTest function. We call it and it's going to work, so our console is going to print foo, but in the second we're going to get an error. So let's go over this. Here we've got the local variable declared, therefore the console log within the function is going to work and we can see foo, but in the second it won't work as it can't find the global variable log. We're going to go over another example on the right hand side now. We declare a local variable right here inside of the function myLocalScope, call it myVar. Let's give it a value. I'll just call it test, and you can see right here this is not going to work as it's not defined. So right here we'll get an error. But if we just call our function myLocalScope, it works and it's going to print out the test. Global and local scope compared in this example. So let's go over this once more. In this case we're going to use the same name for the global and the local variable. We'll call it a sumVar. And as a global variable it has the value head, and as a local it has the value head. And if we call the function, the local variable would be used, so we will get head instead of head. Let's do that here as well. For our myOutfit function we'll add a new variable constant. Let me check what we need. No, it's not myOutfit, we need outerwear. So this is the variable name. Let me correct that here. Outerwear. I'll now change it to sweater, and if we now call the function, we will get the result sweater and not the result t-shirt. So when you call a function, the local variable has, you could say, priority over the global one. So sweater is being returned instead of t-shirt in this example. If we don't return anything inside of a function, the value is going to be undefined. So in this example, we've got a function called addSum with the parameter num. And if we call it, it's going to do something, but it's not going to return a value. So in this case, if we use the value 3 as a num, it's going to be added to the sum, which is 0. So we would get the result 3, but it's not going to be returned. Therefore, the function returns an undefined value. And let's go over this example right here. We've got our function add3. I will add a new one called add5. It shouldn't have any arguments, and it should simply add 5 to a sum. So I write sum plus equal 5. And if we call that, it's actually going to add 5 to our sum, which is initialized with the value 0. But it's not going to be returned, therefore this function add5 only gives us an undefined value as a return. If we would add return sum, this function would return 5 in this case. But as I've said, this is not what this task is about, so I'll delete this line. Let's head over to the next one. It's called assignment with a return value. Let me go over it. So we can use these functions to assign values to variables. In this example, we've got our sum as a variable, and it's equal to the function with the parameters 5 and 12. And if this function sums up values, our sum would now have a value of 17. So 5 plus 12, which would be what the function sum does. Let us call our function processArg with a value of 7. In this case, it would be num7 plus 3 divided by 5. Therefore, it would give us 2 as a value, and we want to store it in our variable processed. So if we would use console log processed, we would get a2 printed. You can see that down here. So processed has now this new value stored. We have used 7 for num, therefore 7 plus 3 equals 10 divided by 5 is 2. It's stored in processed and then printed out. So it works. Let us go to the next task, which is called stand in line. It combines a couple of things that we have already done. At first, we want to add a number to the end of an array, and we've got the push for that. We want to use item as the number that we want to push. So we can see that down here. Before it was 1, 2, 3, 4, 5, and we've used 6 as an item, and we've pushed it to the last position of the array. So now after we've got 1, 2, 3, 4, 5, 6. And then we want to remove the first element of an array, and we know how to do that as well. We use the shift for that. Let's check it at the bottom. 1, 2, 3, 4, 5. We've pushed item to the last position, and we've used shift to get rid of the 1 at the first position. But we want to also return that element. So we use return for this array shift. And this should be what freecodecamp wants us to do in this task. So this shifted value, the 1, would be returned. And we can proceed to the next task. Now the Boolean values are introduced, which are either true or false. So it's just a binary value, you could say. And they're often used in loops, in statements, and I'm pretty sure that's next in freecodecamp. But for now, a Boolean value is just true or false. In this task, we are just supposed to replace false with true. And here we have our first statement. It's an if statement. You always have a condition afterwards, and then a code that is processed if the condition is true. So right here is written if, and then inside regular parentheses we've got the condition, and inside the curly brackets we've got the statement that is executed. Let's check the example. The function is called test. It uses the parameter myCondition and then the if statement with a condition of myCondition. And if this is true, it's going to return it was true. And if it was false, it's going to return it was false. So if we call the function with true as a parameter, it would return it was true. And if we add false as a parameter, it would return it was false. We're going to use a lot of statements, so don't worry if it's not fully clear at the first try. We'll go over this a couple of times. And I'm going to make dedicated videos about that in the future. For now, just write it like this: if normal, parentheses, curly brackets, inside we want to return yes, that was true. And if the parameter isn't true, we want to return something else. You could also write for the condition, was that true equals true? So this is what this actually means. And if it's false, we're going to return, no, that was false right here. Let me copy paste it. And this is usually what an if statement looks like. So it's a binary decision that uses Boolean to decide what's true or false. Let me just call this function once, and if I use true, our condition would be true, and therefore yes, that was true would be returned. You can also compare values to parameters inside of the conditions of an if statement, and we use these equal signs for that. In JavaScript, you usually use these double equal signs to check. So it's different from just using one, which is going to assign values. But if you use myVal and then double equal signs, 10, you're going to compare if my value is actually equal to 10. If it is, it's going to return equal in this case. If it isn't, it's going to return not equal. So 1 equals 1 is true, 1 equals 2 is false, and so forth in these examples. When you write it like this, you don't have to worry about these quotation marks. So 1 equals 1 in quotation marks is actually true when you write it like this. And for example here, we'll just have to set it to 12. Test equals 10, therefore it's not equal to 12. And we would get not equal. But if I change it to 12, we would get equal. We can also use triple equal signs, which would be a strict equality operator. And that's the difference. When you look at the examples, it becomes clear. So in the former example, we had 2 equal signs, and then it didn't matter if we used quotation marks or not. But with the strict equality operator, it does matter. So 3 and then 3 equal signs equals 3 in quotation marks is actually false. With 2 equal signs, it would be true. And now we're going to use this a little bit. So it's once more explained what the difference is between the strict equality and let's say regular equality operator. And there's also type of introduced, so you can check what type a variable is if you use that, or in this case what type a value is of 3. And here we'll just have to add a strict equality operator. It's going to check this, and now we would have a false value, and with just 2 equality operators it will be true. So once more the same explanation that I've already given you. There's also an inequality operator, so we can compare if something is unequal. to a given value, and this is the exclamation mark and then the equal sign. So the first example would read 1 unequal 2, and is obviously true, but 1 unequal 1 is then false. And in the example we'll write val not equal to 99, and if this is true we'll get a return of not equal. And if we change the value down here to 99, val would actually be equal, so therefore this condition is false, and therefore equal would be returned. There's also a strict unequal operator. So it's exclamation mark and then 2 equal signs. So this is also going to test if it has the same type. And here we have our quotation marks again, they make a difference. But the explanation for that is the same as before, where we have to use the strict equality operator and not the strict inequality operator. So in this case 10 is used. If we set that to 17, it would be equal, therefore it's false as a condition, and we would return equal right here. But if we put it into quotation marks, this condition would actually be true, as it's different types. Here's a number, and this is a string, therefore we would get not equal. You can also use greater and lesser than signs. You know that from your very early math classes. You can use that to compare values, and you will get a Boolean return, so true or false. And this is usually used inside of conditions for if statements, so add it right here. Value 100 would return a over 100 string right here. Over 10 should be the condition for the next if. And we can proceed to the next one. And here we have the greater than or equal operator. So it's a combination of these two signs. Once again, you should be familiar with that from your early math classes. So if val is greater or equal to 20, we will return 20 over. Next is greater or equal to 10. Here's the lesser than operator. So for val, we'll need lesser than 25 right here and lesser than 55 to return under 55. Lesser than or equal is just the next logical step. We'll need lesser or equal to 12 to return smaller than or equal to 12. And for the next condition, we'll need lesser or equal than 24. You could say chain certain conditions, and there's this logical AND operator for that. So a double AND sign. And this helps you in not having to nest these if statements. So you can write the same code lines here into this condition. And it makes things a little bit, you could say, structured, gives you a better overview of what your code does. Let's go over the example. We need an if statement and the condition and the curly brackets. And for the condition, we'll need val. We want to check if it's less than or equal to 50. So this is our first condition. And then we use this AND operator, so the two AND signs. And we use greater than or equal to 25. And we can delete this. We want to return, let me check. Return yes. But I've missed something here. You have to add the val, obviously, right here. I've just forgotten to write it. So if the value is less or equal to 50 and the value is greater or equal to 25, we would return yes. We can also use an OR operator. And it's written the same way as the AND operator. So you can check if one condition or the other is true, then a certain code will be executed. In this case, num bigger than 10 or num smaller than 5 would give you no. And everything in between would give you a yes. And once again, this helps you in combining if statements. And it cleans up your code a little bit. Let's write it here. If the condition, let me check what we need. We need our val once again. And we want to return outside if the conditions are met. If val is not between 10 and 20, so smaller 10, or val bigger 20. And therefore we can delete these code lines right here, because we've put them all inside of this one if statement. And we should be fine here. There's also an else statement. So it's usually connected. If you have an if statement, you in most cases also want to have an else statement. So if something is true, you do this, but else, you're going to do something else. In the example, we've got a num, which is either bigger or lesser and equal to 10. If it's bigger, we're going to return bigger than 10. Else we're going to return 10 or less. So let us write another example right here. If val is bigger than 5, the result is going to be bigger than 5, but else we're going to return 5 or smaller. And we can delete the rest of the code. In some cases you may have multiple conditions that you want to check, and you can use an else if for that. So in this case, if number is bigger than 15, something is happening, else if number is smaller than 5, something is happening. And if both of these conditions aren't true, the else is being executed, so between 5 and 15 in this case as a return. Let us convert what we've got here to an else if statement. So if val is bigger than 10, it can stay. Else if the condition val is smaller than 5, we want to return smaller than 5. And in all other cases, we're going to use an else, and that will return between 5 and 10. Once again, don't worry too much. If this is completely new to you, you're going to use such statements a lot in JavaScript. So if you expose yourself to new coding tutorials and stuff like this, you're going to stumble over it time and time again. And over time, you're going to learn it. One word of caution is that the order makes a difference. And in the example you can see that. The first foo function, it has a different order than the second function right here, which is called the bar function. You can see that with the first condition and the second, they are reversed. So if we call both of them, we'll get different results. For the first one, foo, with a value of 0, let's check it. Value of 0 would be x smaller than 1, so it would return less than 1. But if we use bar 0, it would give us less than 2. Just because the order is reversed. So keep that in mind when you design your if statements. In this case, we'll just have to fix it right here, change 5 to 10 for the if and the else if condition and return. And then we're good with this task. And we can move on. Let us chain if-else statements. So if you've got multiple conditions, call it a chain of conditions. You can add multiple of these else-if conditions after the initial if. In example, we need tiny, small, medium, large, huge, so 5 in total. Our first if condition is num smaller than 5. Then the else if follows. We'll have to return small, and for the condition we'll need num smaller than 10. I now just copy this format and I paste it. Num smaller than 15 should be medium. Num smaller than 20 should be large. And the final statement, we don't need a condition anymore. We can directly write else, because these includes all other cases. Or we can just delete this part right here and change small to huge. And this is how you usually write these chained if-else statements. And here we have a simple example that we can use to determine how a certain number of strokes is called. In golf there are specific terms for that, I guess. I've never played golf, but I've heard a couple of them. For example, hole in one, everyone has heard that. And if you are on par, strokes and par for a given hole are equal. So let us create a couple of if and else if statements with the conditions that are defined here. And we've got the strokes, which is the number of strokes that a player has needed for a certain hole. If it is equal to 1, we've got a hole in 1, so that's what we want to return. Then we need an else if statement. We'll define the next condition. And this time it's about is stroke smaller or equal to par minus 2. Then it's called an eagle. The next else if, I'll just copy paste it. It's par minus 1, but be careful, it's not smaller than. or equal, it is only equal to par minus 1. So don't write it like this. We'll have to have these double equal signs, and this is called a birdie. Afterwards, we have strokes equal to par, which is simply called a par. We've got a bogey and a double bogey. Finally, we can close it with an else, and we don't have to define a condition, as everything above par plus 3 will return go home. And we're good with this example. There aren't just if and else statements, there's also a switch statement, and most often it's easier to write if you've got multiple conditions. But for switch statements, you will call these conditions a case. In the example, we've got a parameter lowercase letter that's used for the switch, and the cases are either A or B. And if this case is true, we've got the specific console.log. It writes in uppercase A or A, uppercase B. For cases, it's all strict equality. So when they compare the parameter that's given in the initial switch in a normal parenthesis to the value of the case, it's all strict equality comparison. Let me just write an example and you can see how this works. Normal structure is always switch, normal parenthesis and curly brackets, and inside we've got the cases. For this example, we'll need the value variable, and we want to compare it to certain values. And after this value, so the specific cases, you also want to add a break. This is basically going to tell the code that if a case was true, after it's going to stop. So the following is not executed anymore. Let me just write some pseudocode like this, and I will check what we actually need. So we've got numbers as values, and then we want to return words. So the alpha is what we want to return and not what we want to compare. So it doesn't belong here. Let me fix that. So in case our value is 1, we want to return the string alpha. So put it in quotation marks. If our variable val has the value 2, we want to return beta. I'll just copy paste this. If our value is 3, so case 3, we need gamma as a return, and case 4 is delta. And as you can see, every single one of these cases has a break after the return. Don't forget to have when you write your switch statements. We also can add a default option to a switch statement. So in case our parameter doesn't meet any of the requirements for the cases, a different code should be executed, and this is what the default is for. So again, I think it becomes clearer if we just go over an example. The one that's given, if num doesn't have value 1 or 2, the default is going to get executed, and it doesn't matter what actual value num has. All that matters is that it's not equal to value 1 or value 2. We'll go over the basic structure of the switch, so normal parentheses, then curly brackets, and we want to test our val variable. Case A will return the word apple. Afterwards, we need a break. The next case is B. We want to return bird. Again, don't forget the break. Case C is cat. And now for the default. As I said, it doesn't matter what actual value the val variable has. It could be X, Y, Z, doesn't matter. As long as it's not ABC, we're going to get the default return of stuff. And this is how you write your switch statements. Usually they always contain a default case, but it doesn't have to. We can also connect different cases. So if we want to have the same return for more than one case, we can just write it like this, leave out the break. And once again, the code goes top to bottom. So case 1, 2, 3 in this example would give the same result after it there's the break, and case 4 would give us a different result. In this case, case 4 doesn't need a break as it's the last case, and after it there is no code inside of the switch statement, so you can actually omit the last break. It doesn't matter. In our example, we need case 1, 2, and 3 to have a return of low. After it, we need the break. Case 4, 5, and 6 need to return mid. And again, don't forget the break. And case 7, 8, 9 will have the return of high. Most often when you write code, you can write it in various ways to achieve the same result. So you already know if and else statements and the switch statement, and you can replace them with one another. In most cases, switch statements are easier to write and easier to understand. So whenever you can replace an if and else if with a switch, it's a good idea to just do that. Obviously there are always exceptions, but it's a general rule that you can live by. Let us replace the given if, else if statement or the chain right here on the right hand side with a switch. We have the cases of Bob, 42, 1, 99, and 7. And we want to have different returns for each. So we gotta create a case for each of these values, and our variable that we want to test for these cases is the val variable once again. And for most people, these switch statements, as I've said, they're easier to read, easier to understand than all of this if, else, chain stuff. So whenever you can replace it, try to. But I've missed something here. Let me check. The exclamation mark. Now it should work. I'll jump ahead. You can also make your statements or your functions return Boolean values. So it doesn't have to be a number or a string. We can also return true or false. And in many cases you actually want that. Here in the example, we want to check if A strictly equals B. And if so, we want to return true, else we want to return false. Or we can just write it like this. Just going to omit all of the if and else stuff. So if we call the function is equal, we are just going to return A strictly equals B, which would be true if it is. And if A is, for example, 7 and B would be 5, it will return false as the statement A strictly equals B is false. Therefore, this little code line right here can replace all of the if and else below. And we can simply delete it. And we're good. Let's check the next example. Alright, whenever we have a return inside of a function, everything that comes after it is not going to be executed. So a return is basically a break. You could see it as such. So whenever we've got a return, everything after it doesn't really play a role anymore. In this case, the console.log bye-bye will not be printed, as we've got a return above for the function myFun. Let's modify this function apptest so that if A or B are less than 0, then the function should immediately exit with a value of undefined. You can see that below the comment on the right hand side there is a math operation, so return math.round and so forth, and it won't get executed if we just write this code. So if A is smaller than 0 or B is smaller than 0, we want to return undefined. It's a keyword, so I can just write it here. And if we do it like this, this entire math operation is omitted, which comes after it inside of the function. And we've passed this. Here you get another somewhat real-life example. What we need to do here is we need to check what kind of cards we have. And for the certain cards, we'll add 1 or we'll subtract 1 to count our cards in blackjack. And if we have a positive value, we should bet. If we have a negative value, we should hold. We could, for example, use a switch statement at first to adjust our count. The count is given. It's called let count equals 0 here in the first line. So we've got it declared and initialized. And we'll use it now for a switch statement. So we want to test the count. For the various cases, we've got our table on the left hand side. So for the case 2, 3, 4, 5 and 6, we want to add 1 to our count. Could write it like this: count equals count plus 1. But you also know already that you could write it shorter like this, or just count plus plus for the incrementation. The next cases, 7, 8, 9 doesn't really play a role, as we're not going to change our count if that happens, so we can neglect that for our switch statement. Therefore the next case would be a 10, and this would be -1. Same goes for all of the letters, J, Q, K, A. Therefore we can chain them and only add a return to the last one, which is the A. And this time we've got count equals count minus 1. And again, we could write that shorter like this, or just count minus minus. Now we want to check what we want to have as an output. If it's a negative value, we want to hold. If it's a positive, we want to bet. So we have determined our count, but now we want to check if the count is higher than 0. If this is true, we want to return the count and then afterwards bet. And in between we need a space. So don't forget that. And for all other cases, so else, we want to return hold and also the count before it with a space. In this case, we don't have to define a condition as it doesn't matter. The count can either be higher than 0 or equal and lower to. So we can directly add our return right here and we don't need an else if. And that should be the solution to counting cards. Now we are introduced to objects. Objects might be a little bit harder to understand, I would say. So it's not equal to an array. And it's not even a multi-dimensional array. You could see it as a collection of variables. Maybe that makes sense. So in this case, we've got an object called cat. In this example, we've got an object called cat, and we can store properties and values for it inside. So name, whiskers, legs 4, and so forth. Values can be everything, Boolean, numbers, strings, whatever. And even the properties can be numbers, strings, like here in the another object example. The way to write it is always the same. So you declare it, in this case by giving it a const variable type, then a name, afterwards an equal sign, and then you need these curly brackets. That way you're going to determine that an object is coming. In it, you'll add your properties. For our dog, we need name, legs, tails, and friends. And now you give it values. For name, we're going to use a string. Let me just invent something. Let me call the dog Charlie. And you can see right here we need a comma to separate all of our properties. For legs, we'll use a number. We don't need quotation marks for that. And let's say here is 8 friends. And for the last value, you don't need a comma either. So we can just move on. But I've made a mistake here. Let me check. Other friends should be an array. So not just a number, we should give an array of friends. The way to do it is to use these brackets. And inside, let's just add more dog names. I don't know, like Buddy, Rocky, Sadie, whatever. These should be typical dog names. And now it should work. We can access the information inside of objects. And we have two ways to do that. Basically, we can use the dot notation and the bracket notation. Here the dot notation is introduced. Let's just look at the example. We've got my object, which is the object declared and initialized right here. It has two properties and connected values. And if we want to give a new variable prop1 val, one of these values of our object, we can use the dot notation, and after it comes the property. And the second variable here would have val2 as a value, as it has dot prop2. If we go over one more example on the right hand side, it becomes clearer. Here's the object, the test object. And we want to give our head value ball cap as a value, so we use test object dot and then head. The shirt value, it should get the value jersey, so we use test object dot shirt. Let's go over the bracket notation, which works similar. But in this case, we'll just use brackets and then the name of the property. On the right hand side again, we've got two variables and we want to give them certain values from our object, which is the test object. Let's check it. An entry should be given an entree value, which is hamburger. So we use the brackets, quotation marks, and afterwards an entree. And the drink value should be given brackets and then the drink property right here. And therefore it will get the value water. We can also access the properties with the variables. So here we have our dogs object, and we're going to use the value hunter. Which is the property of our dogs. We'll pass it to my dog. My dog is then used in the next code line. So dogs or object, and then the bracket notation my dog, which was called hunter. This is then passed on to my breed, the new variable, and this is then printed out. Let us go over an example. On the right hand side we've got our test object again. And we want to set the variable player number to the variable 16. So 16 in this case is the property of our test object. Let us set it right here. Player number 16. And now we want to use another variable, player. And we'll use test object bracket notation and then player number. So it will be test object 16, therefore it looks at the object, finds the property 16, which is a value of Montana, and this is then passed on to the variable player. Be careful not to use these quotation marks, as we have a number and not a string. In the example on the left we have strings, but here our test object has numbers as properties. Therefore, don't use these quotation marks. Let's see how we can update properties inside of objects. For example, we want to change the name property or the value of it camper to happy camper. We can use dot notation for that. So our dog, the name of the object, dot the name of the property equals the new value that we want to give it. You can also use brackets notation. So once again, the name of the object, inside of the brackets, the name of the property equals the new value. Let us do this for our myDog object in the example on the right hand side. We want to change the name from coder to happy coder. So we need the name of the object. We can use dot notation. We need the name, which is the property name, and set it to the new value happy coder. Let's check the brackets notation. It works the same way. We cannot just add new values to existing properties, we can also add new properties to objects. All you have to do is to use the object name and in dot notation add the new property and its value. Brackets notation is below, so it's easy to do in JavaScript. In the example, we need the myDog object dot the new property bark is equal to its value, which is woof. We could also do that in brackets notation, as you can see here. I'll leave it up to you to do that yourself. Let's look at how we can delete properties. There's our keyword delete. It comes before the object name and then dot the property name. Let us delete the tails property from our myDog object on the right hand side. So what we need is the object name myDog, then dot tails, and before it we need our keyword delete. And again, we could also use the brackets notation. I'll leave it up to you. Sometimes we want to look values up or even the properties inside of objects. Let us do this instead of using a switch statement in this example. Here on the left hand side we've got an example for the object article. And if we want to look stuff up, we can define a new variable article author, set it to equal article the object name, and in brackets the property name. So this author value would have now been passed to our article author variable. Let's look at this example for value lookup. We set it to article value, and value is equal to title. Therefore, how to create objects in JavaScript would now be the new value of value lookup. Let's convert the switch statement on the right hand side. How can we do it? We'll start with a new object. We'll call it lookup. Don't forget the equal sign in between these curly brackets and the object name. And there's also a semicolon at the end, right here. And inside, we're now going to add the properties, which are the case values, so Alpha, Bravo, Charlie, Delta, Echo, and Foxtrot. And we'll set the values Adams, Boston, Chicago, Denver, Easy, and Frank. But be careful here, we don't need equal signs, we need these double dots. So this is also, let's say, a trademark or an indicator of having an object. And you may know this way of writing properties and values from CSS. And finally, we want to look it up. So we'll use our result, the variable that's declared on top of our object, and we set it to lookup our new object. And inside, we want to have the val right here. And that way we can look up values or properties of our object and set this value to our result variable. We can also check if an object has a certain property. And there's a method that exists in JavaScript that we can simply use. It has own property in the parentheses. Let's go over the example on the right hand side. We simply want to check if our object, so the obj, has a certain property of checkprop. And we actually need an if statement for that. So let us write it. In the case it is not found, so we need an else statement, will return not found. And if it is found, we'll return, let me check it again. We want to return the properties value then. So we need the object obj. We can use the brackets notation here. So checkprop is the property that we want to use then to find the value that we want to return. And for the condition we need obj.hasOwnProperty and in parentheses the checkprop. And now this should work. Let's move on to more complex objects. On the left hand side there's an example given, our music, and it's actually an array, not an object. You can see that at the start and the beginning there are these different brackets. And inside of this our music array, we've got an object. It's this one with the curly brackets. And we could add more objects to it, so you can also create arrays of objects. And inside we've got properties nested, and one format is even an array itself. So we've got an array with an object nested, and inside of the object there's another array nested. Things can get very complex. We could add more objects at the top right here, or after our first one. We just have to separate them with a comma. And this is what we're going to do now on the right hand side for our My Music example. It's an array once more. And we want to add properties for a new example. I'm just going to invent some values. They are not important. Important is that you add the comma right here, so that we have an array of objects. Then use the curly brackets. And afterwards we can add the properties. We need artist, title, release here. And formats should be an array. Let me just use, I don't know, Led Zeppelin. I don't even know when it was released. Let me just say 1978 or something. It should be pretty close. And for formats, as stated below, it needs to be an array. And even for the example Billy Joel, it is. So use these brackets and then add, for example, CD. And the other ones that are given, what is it, A-tape and LP. And we should be good here. But alright, the release here, it should be a number, not a string value. And in the example Billy Joel it is, so my mistake. We don't need the quotation marks here. But now we should be good. If you want to access nested objects, it's once again a little bit more complex, but it's still the same procedure as we've already seen before. Here we've got our storage, which is an object. It's the entire thing. And you can see that inside, for example, we have desk, which is an object itself, and cabinet, which is also an object. So you can nest objects inside of objects. And if you want to access them, you can use once again bracket or dot notation. Combine it. So in this case we have our storage, we access the object, then cabinet, which is the object inside, and we find the property top drawer, which is this one, which is also an object, and we'll find its property folder 2, which has the value secrets. The second example, our storage, again, we'll find the desk, which is here, and then we'll find the drawer. So the value stapler would be the second example. Let's go over the example on the right hand side, my storage. And we want to find the glove box. So glove box maps is what's inside of my storage. What we need is my storage, the name of the entire object, dot. And there is the car, then dot inside. And finally, we want to find the glove box property. So let us use the brackets and then add the property name. And now the value maps should be passed to our variable glove box contents. We can also access nested arrays. Procedure is somewhat similar. And we'll get our index indicators again. so we've used them a couple of times already in this course section. For example, here's our pets, and we'll find the index 0, which is this object right here. Then .names, got it right there with an index of 1, which in this case would be Fluffy. So Meowser would be index 0. Remember, it all starts with a count of 0. Therefore Fluffy is 1, KitKat would be 2. Second example, our pets 1 would be the second object, their names, with an index of 0, this would be Spot. Let's go over the example on the right hand side. We want to find the trees of my plants. So we need my plants, that's the array name. Then we need the brackets and to find the index position that we need, which in this case would be 1. So it's the second object right here. And now for trees we need to find the type. And this would give us the value trees. But I made a mistake here, let me check it. We need the second item in the trees list. So I haven't read that correctly. So we need pine. This is what we actually need. So let me change type to list. And then set the index position to 1, because fir, that would be 0, then pine is 1 and birch is second. But now it works. Let's go to the next task, the record collection. So we've got a function update records, just a couple of parameters, records ID prop value. And below it we are calling it. So with a couple of values, for example, the record collection value for records, which is our object on top, and we want to create if statements so that we can alter our object. Let's go over it step by step. So this is the first one, if prop isn't tracks and value, so prop isn't equal to tracks, and value isn't an empty string. So we need these end signs. And then value is not equal empty. We want to update or set the album's prop to value. So we need our records, the first parameter. And as I've said, when it is called, it's called record collection, which is our object. Then we need the ID, which is the numbers of our specific object elements here. So it's objects inside of objects. And then we need the property, so artist or tracks. When it is called at the bottom, it's artist. And we want to set that to the value, which is in the example below ABBA. And that should be the first bullet point right there. Now let's go to the next one, else if. If prop is tracks, so prop equals tracks, but the album doesn't have a tracks property. So end records ID doesn't have a tracks property, so we need this method that we've used in the previous steps. So dot has own property, and for the parentheses we need our tracks, because we want to check if tracks property is there. And we need to set that to false. So if it doesn't have a tracks property, we want to create an empty array and add the value to it. So again, we need our records id prop, and we want to set it to the value, but be careful, you want to create an empty array. So just write it like this. And this should be the next bullet point. You can see that as an example right here for Robert Palmer. There's a tracks with an empty array. And this is basically what we would create. Let's go to the next bullet point, else if. Let's check the condition first. If prop is tracks, so prop equals tracks. And value isn't an empty string, so and value not equal to what do we want to do now? We want to add value to the end, so we need our push brackets id prop, then dot push, as we want to put it to the end of the tracks array, and we want to push the value to the end. So put that inside of the parentheses, and we should be good here as well. Let's go to the next one, else if. The condition is if value is an empty string, so value equals empty. Delete the given prop property from the album. So we need our records again with an ID and the property. And we want to delete that, so we use the keyword delete. And this should also be fine. And I believe that should cover it all. Let me run it and check. Yeah, we're fine here. A little bit more of a complex task this time. Let us go over it once more with the first condition. So prop un equals tracks and value un equals empty. We'll add the value to our records. As you can see here, the records is always our record collection, which is the object here on top. And the ID is the ID that fits the record. We use artist and ABBA as prop and value in the example below. The next bullet point was if prop equals tracks. And records ID doesn't have a property of tracks. Third condition was prop equals tracks and the value is not empty. Then we're going to push a value at the end. And if the value is an empty string, so value equals empty, we're going to delete the id prop. A little bit more of a complex task, I have to say. Might be also a little bit frustrating for beginners, don't worry about it. I think there was a little bit of a jump in freecodecamp. Usually they provide very step-by-step, very detailed tasks, and this one was already a little bit more complex. Just go over it with my walkthrough, and with more experience it makes sense. And you should be fine, and over time you're going to learn more and more. And the more you code, the more you'll understand even such more complex problems. Let us use a while loop now in the next task. So we can also use a loop that does the same job or the same code time and time again. In this case, we'll use our array and push a value to it. It starts at 0 as let I equals 0, and we'll use I to push. And we'll push the I value, but we only do so as long as I is smaller than 5. So when it becomes 4, it's the final time it's going to get pushed. And when it's then incremented once more, it becomes 5, then the while condition is false, and therefore the code isn't executed anymore. Let's go to the right hand side. We'll declare a new variable, I equals 0. We want to add the numbers 5 through 0, so we'll start with our condition like this, I bigger equal to 0, but we'll have to set the initial value to 5, and then we'll have to write I minus minus, so every time the loop gets executed, we're going to subtract 1 from I. And my array dot push and I. Let me check if that was correct. It was. And now I'm going to explain it to you in detail. So here's our variable I equals 5. And in the first round for the loop, I is simply 5, which is bigger or equal to 0. Therefore, the while loop is executed. And my array gets the push of I equals 5 added. Afterwards, we have I decremented with 1, so I becomes 4 in the second round. This is still bigger or equal than 0, therefore it is added via push. As I is now 4, the 4 is being pushed. Once again, it gets decremented to 3, and so forth. And finally, let me check, 4th round would be I equals 2, 5th round I equals 1, 6th round it would be I equals 0. And then the 7th round I would be minus 1, and now the condition for the while loop is false. So I equals 1 is not bigger or equal than 0 anymore. Therefore, at this point, our while loop gets stopped and nothing gets pushed to our myArray anymore. So this is the way you can read these loops. If you would have forgotten the equal sign right here, it would have already stopped at the 6th position. So that's what we needed, don't forget it. We also have for loops. It somewhat works the same as a while loop. But you can see that where we have put the condition for the while loop, there's a little bit more text now inside of the for loop. Let us go over the example and I explain to you what that all is. So here's the for loop, here's the parenthesis, and at first we're going to declare our variable, in this case the I equals 0. Then B is for the condition, so I is smaller than 5, and then I++ is the incrementation. So basically everything we've done for a while loop, we've pushed it all inside of the parenthesis for the for loop. We'll go over yet another example on the right hand side. Just write it like this at first, let I equal 0, and then I smaller something, and then I++. Now we want to check what this loop is supposed to do. Well, we want to start right here at I equals 1, because we want to push values 1 through 5. Therefore we can write I smaller than 6, or I smaller equal to 5, it will be the same. We want to increment it, so I++ was correct, and we want to push these values to my array. So all that we need is to put an I right here. Let me check it first. I haven't made any typos, so that's correct. So again, in the first round, I would be equal to 1. Therefore the condition is true, as 1 is smaller or equal to 5. So my array pushes the value of 1 to the array. Afterwards, I is incremented, so it becomes 2 for the second round. 2 is still smaller or equal to 5, therefore 2 gets also pushed, which is the new I in the second round, and so forth. And the loop stops when I becomes 6, because then the condition for the for loop isn't true anymore, as 6 isn't smaller or equal to 5. So in round 6, I doesn't meet the criteria for the condition to be true anymore, and that's when we have to stop for the loop. We can also use different ways to increment our counter. So far we've always used I in this case, so we don't have to increment it all by 1. We can, for example, here increment it by 2. You just have to write it differently than right here in the parenthesis for the for loop. So I plus equals 2 would be a way to increment I every round by 2. Let us write our loop on the right hand side. Again, we'll need the for. Then let I equals some value. Let me just use 0 as placeholder. Then I smaller than something and I++. And inside we want to push something to my array. It's usually I in these examples. Now let's check what we actually need. We need the odd numbers from 1 through 9. So our initial value for I should be 1. Final value should be 9. So smaller than 10 would work, or smaller or equal to 9 would also work. Whatever you want to use here. But we want to only use the odd numbers. So 1, 3, 5 and so forth. So we have to increment by 2. I haven't made any typos, it's correct. Let's go over it a final time. So first round, I equals 1, condition is true. Therefore 1 is added to the array and I is incremented by 2, which makes it 3 for the second round. 3 is still smaller than 10, so the loop is executed and 3 is pushed to the array. Then it's incremented by 2, which makes it 5, then 7, then 9, and when the I becomes 11, the condition becomes false. It should be the 6th round, if I have miscalculated here. And when the condition is false, so 11 isn't smaller than 10 anymore, the loop stops. Sometimes you don't want to increment, but you want to decrement your counter. And you can do that as well inside of a for loop. So in this case, we'll decrement it by 2 for every round, so we'll get from the starting value 10, 8, 6, 4, 2, and when it becomes 0, the condition is false and our for loop stops. Let's write it again. So for that I equals value, I bigger or smaller than something, and I plus plus. We want to push it to our array once again. And now let's have a look at the actual values that we need. We push the odd numbers from 9 through 1. It must be bigger than 0, because 1 is our final value, and we want to use the odd numbers. So minus equals 2. So every round our I is being decremented by 2. Now we want to iterate through an array with a for loop. So this is also possible, and this is actually a very common task. In the example on the left hand side, we've got an array 10, 9, 8, 7, 6. And we want to print out all of these numbers. You can use a for loop. Initial value is 0. As long as it is smaller as the array length, we'll execute the loop and increment by 1. So at first it would print the 0 index position, which is 10. Then it would be incremented to 1. The index position with a value of 1 is 9. And so forth. Once again, keep in mind that we always start counting at 0 when it comes to these index positions. But the array length in this case is 1, 2, 3, 4, 5. So the final index position would be 5 minus 1, which is the position 4. Let's go to the right hand side and create our example. What do we need? At first we need a variable. Let me call that const total equals 0. We create our for loop. Let I equals value, I smaller than something, and then we'll increment it. And we want to use the total value and add all of the values in our myArray to it. If we have something like this, we can't use a const variable, we need a let. So let me change that. We'll start with let equals 0 because this is our first index position. We'll want to increment by 1, so we can leave that. But it's got to be smaller than our myArray.length. And this should be correct. Let me check it. It is. Let us go over the individual rounds. So the first round, I equals 0. And I plus 1 for each round until I is as equal as our array length, which in this case would be 5. As I've said, in the first round, I equals 0, and the first position in the array is A2. And after the fifth round, we should have I equals 5. Therefore, the condition isn't true anymore and the for loop is stopped. We can also nest loops. And now it's getting a little bit more complex. But for example, here our array is multidimensional, and we can use 2 for loops to cycle through that. You can see the outer for loop right here with the variable I as the cycle for the outer index. So this would be 0, this 1, this would be the index 2. And the inner loop, it cycles through these positions one by one. So it goes from 0 to 1, and every time the outer loop gets cycled through again, we'll go from 0 to 1 again inside of the inner loops. This is usually the structure that you need, and we can use that to multiply all of the values inside of an array. And this is what we're going to do. Be careful when you use the condition, because the second condition, it uses the outer variable again as the index. So it's not the same array length. Let us check this. So we'll use multiply all, which is the function. We've got the variable product already declared. It has a value of 1 now. And we want to use this array right here. So it has the same name as our example on the left hand side. Let's create the outer loop first. So let I equal some value, then a condition, and then we'll increment it. And this for the outer index. And inside we want to have a second loop. Let's use j. And again, we'll set it to a value, create a condition, and then increment it by 1. Now let's check what we actually have to do. We need our product variable. And we need to set it equal to product multiplied by the array with the 2 index positions. So I and j. We're cycling through that. And then we're going to multiply it with the product each time. So again, our outer loop gets through these first, you could say this first dimension of the array, and the inner loop goes through it one by one inside of these. For the conditions, we need the array length for the outer. But for the inner, so our condition with the j variable, we need to check the specific arrays that are inside of it nested. So we need array with an index of I.length. So we'll go from one array to the next and check its length for the inner loop, and now it should work. And we can go to the next task, and there's a do while loop as well. And again, you can use a do while loop, you can use a while loop, you can use them interchangeably from time to time. For example, here we're going to rewrite a while loop and turn it into a do while loop. In this case, on the left hand side, we have I equals 0. It's going to get incremented each time, and it gets pushed to the array until we've reached I equals 5. Therefore, 4 is the last value that gets pushed to our array. Read through the entire text yourself. If you're unfamiliar with this, I'm just going to go over the example on the right hand side. So we've got a while loop and we want to change it into a do while loop. So we need do, we need our array and a variable that's already given up here. And after the do, we need the while. For do, we want to, let me check it below, we want to push only the number 10 to my array. So my array push and then a value of 10. Or we can just use our variable right here, the I, which has an initial value of 10. And if we afterwards increment it by 1, it becomes 11. So we'll use that as a condition. And we'll make it I++. So the moment it becomes 11, we are done with our code. Here's another more, I would say, complex or not beginner friendly concept. It's called recursion. And it's one of these concepts that you have to read over multiple times and use multiple times to fully understand it. In this case, we have a function called multiply with 2 parameters. And we'll cycle through the array as we've done previously and create a product of it. But we can also write it a different way. Instead of calling the function, we could also write it like this. So multiply with the parentheses, we use the parameter and n-1 times the array with n-1 as an index. Here's another example. Let us write it up here. We need if and else. For the if condition, it needs to be smaller or equal to 0. But instead of returning 1, like in the example, on the left hand side we'll return 0. And for else, we'll return our sum with the parameters array and n-1. And now we are not going to multiply it, as we have the sum, we need a plus sign. And for the index position we use once again n-1. Let me add some spaces so that it looks like the example on the left hand side, and you can see this is almost the same, but we're not interested in the product, so it's not a multiplication, we're interested in the sum. So this is what your code should look like. Once again, don't worry if you haven't gotten around it the first time, it's a more complex concept. Let's go to the next task. Profile lookup. So we have a lookup profile function. It has name and property as parameters. The example below, it has the values Akira and likes. And we definitely need if and else statements. Let us go over it step by step once more. So we'll start with a for loop. We need to check if name is an actual context first name. And let us stick to the variable I, not x. We've used it so far, so I don't want to confuse you. I equals 0 and I smaller than our contacts array right here, context.length, and I++. So you already know this. So it's the usual way to write for loops. And now we need the if and else inside to check if name is an actual context first name at first. Let us do this in a condition. So contacts with the index of I. So here we have it, for example, for the Akira, it's the first name. And we want to check if it's equal to name. So for the first one here, it would be true. And if that is the case, we need another if statement right here. So both should be true. Therefore we add another if with a condition. We'll nest it inside of the first one. And this time its context I has own property with a value of prop. If both of these conditions are true, we want to return the value of the property. So nested inside we can already return our contacts of the index I, and then we need to access the property, which is called as the argument prop. So this is what we want to return. Which is this sentence right here. If name does not correspond to any context, then return a string no such contact. So how can we write this? Well, we add our else right here. But the next sentence is more important. At first, we want to add it right here, because if prop does not correspond to any valid properties of a contact found to match name, then return a string no such property. So this is what we need to add first as our else, as this is the inner if else statement. And the outer if else statement is right here where it says no such contact, so that's what we want to return. Let me see where the correct bracket was. It should be right here. So we can directly return no such contact. And now it should work. Let us go over this once more. So it's a little bit more complex. We've got nested if statements. So again, our function lookup profiles has these two arguments. And we want to check if the name is the actual contact's first name. So this is the first if condition that we've created right here. But that's not enough. We also want to check if prop is a property of that contact. So both have to be true for us to use the next sentence right here. So we want to return the contacts at I and prop. If name does not correspond, we want to return no such contact, and we can put it outside of our if statements. And if prop does not correspond to any valid properties of a contact found to match name, then we want to have no such property returned. Therefore, it's the else statement for the inside if else statement. We can create random numbers, or in this case random fractions, by using math random. This is also a function, but it's an inbuilt function in JavaScript that you can just use. You don't have to create it yourself. It always creates fractions between 0 and 1, but it can never be 1, but it could be 0. So if we just want to return a random number, we write it like this: return math.random. We can use that to play around and, for example, create random whole numbers. Let's just check this example. We use math random to generate our fraction, then we multiply by 20. And afterwards we use math.floor to round it, which is another function that's given in JavaScript. Let's directly go over what we need, and then I'm going to explain it step by step. So we want to return a random number, so we need math.random. It's already given here, but it should be a number between 0 and 9. And it should be a whole number, so we'll use math.floor and put parentheses around the math.random. And we want to have, as I said, numbers between 0 and 9. Therefore, we'll have to multiply it by 10 right here. So if we go over this step by step, let's say math.random is equal to 0.7, which is created randomly. We will multiply it by 10, which would make it 7. And the math.floor would round it down, which in this case it doesn't have to. Let's just say math.random creates a different number, maybe 0.578. We will multiply by 10, which would be 5.08, and the math.floor would round it down to the nearest whole number, which would be 5. We can also generate random numbers within a range. And this is always written the same way. Just like this. Here it is given on the left hand side in the example. So we use max and min. We can give that specific values or use variables, whatever. In this case, if we use for max 10 and for minimum 5, we would get 10 minus 5 plus 1, which would be 6. Then a random number would be generated by math.random, and we'll multiply that with 6. Let's just say we would get 0.51. Times 6 would be 3.06, and math.floor rounds it down to A3, but afterwards, don't forget, here's also the plus min, and min was in our case the 5, so we would get a number of 8. And it doesn't matter what number is randomly created, it will all be inside of the min-max range. To pass our task here, to pass the tests, we'll just have to use the same code line, but we'll have to change our variable names. So we use my min and my max instead of min and max. But afterwards we should be good. There's another function that's inbuilt, it's the parseInt, and it can turn strings into numbers. In this example, 007 as a string would be turned into an integer 7. If you put in, for example, words, it would return NaN, so not a number. It wouldn't work with it. Let me check what we have to do in this example. We'll have to return a parseInt of the variable string. You can also use a radix in relation to your parseInt. So if you, for example, want to use a binary system, you use 2 for radix. If you want to use a decimal system, you use the 10 for radix and so forth. And it automatically turns these numbers into the integer with the correct radix. Just as an explanation, the binary number system works like this. So the first number is always for 1, the second for 2, third for 4, and so forth. So if we would parseInt 11 with a radix of 2, we would get the integer 3, as it's 1 times 1 plus 1 times 2 equals 3. Let's go over this example. 10011 would be 1 times 1 plus 1 times 2 plus 0 times 4 plus 0 times 8 plus 1 times 16. And that will give us the integer of 19 in the decimal system. So this is how the binary number system works. And in this example, we'll just use the parseInt again. With our variable, it's str, and we want to convert it from a binary number, so we need a radix of 2. And we also want to return it, so we'll add the return before. There's an easier way to write these if-else statements. As the A, you add the condition. B, in this case, is what should be executed if the condition is true. And C is what should be executed or returned in this specific case if the condition is false. So you can rewrite if-else statements by doing that. Let us go to our function checkEqual, and we want to return then a condition. So if A equals B, as we want to check if two numbers are equal or not. If they are equal, it should return the string equal, so question mark, then equal. And if it's false, we want to have not equal returned, so let us add that right here. If you have more than one condition, you can write it the same way, so you don't have to use if, else statements like here in the example. You can all write it like here. It's a good idea to write it in these lines as it's a little bit better for overview. We'll go over one example on the right hand side now. So let me check it. We want to return something. We want to check if the number num is positive, negative, or 0. So if it's bigger than 0, it's going to be positive. The other condition would be if it's equal to 0 or smaller, you decide. Let me write num equals 0. We want to return 0. And the last case, it doesn't need a condition, because if the other two aren't true, this condition is automatically true. Therefore, we can just add it as a third case, so the number would be negative. We're getting closer to the end, but before we do, there's more recursion. In this example, we want to create a count down. An example is given for a count up. So we can use the basic outline. So instead of counting up and putting these values into an array, we want to count down. So it's not 1, 2, 3, 4, 5. We want to go from 5 down to 1. But as I've said, the structure is the same. We use the if statement first. We're going to use the same parameter n in this case. It has to be smaller than 1, and we want to return an array. It's going to be empty here. And for the else statement, we'll declare a new variable. Let's call that ARR for array. And then we'll call our function. It's called countdown. So don't mistake it for the count up in the example. But n-1 is still the same. And now we want to use our array and add the numbers to it. But we can't use push, as this would be a count up. We want to use unshift instead. So that way we wouldn't start with 1, 2, 3, 4, 5. We would start with a 5 and then go down to 4, 3, 2, 1. So unshift can be seen as the opposite of push somewhat. But we want to push n. And finally, we want to return our array, so don't forget that. And this should work. Where we use recursion to create a range of numbers, and this range isn't given. It's instead used as arguments right here for a range of numbers function. But again, the structure is the same. Let me first delete this line and I'll add my if statement, and inside of it we want to return the array, which is empty. In this case, we'll use endNum for our condition in the if statement. It has to be smaller than our start num. So previously we only had one argument, and it had to be smaller than 1. In this case, we'll use the start num. And for else, we'll create our new variable. Let me check what we actually need here. I'll just call it numbers. You can call it whatever you want. Now we use our function. And inside of it, we use the start num and the end num minus 1. We want to use our numbers afterwards. And we can use the push once again. And as a value for it, we'll need the end num once more. Afterwards, we want to return it. So don't forget to return your new variable, in this case numbers. But now it should work. And we are through. It took us more than 3 hours to get through it. I hope that I've explained everything in detail so that you could pass these tests yourself and understand at least most of it. Once again, the recursion stuff might be a little bit more of an intermediate topic. In general, you learn coding by simply doing it and having to repeat it all of the time. So you shouldn't expect to see it once, do it once, and then be able to recall that and recreate it yourself and understand everything. We're going to go through the freecodecamp curriculum some more. There's, for example, the JS section next, which is also JavaScript. But I've also planned to make more videos about JavaScript in detail. So we're going to repeat all of this stuff in the future and even use it on specific projects, and things will become more clear. In general, I hope that this video was helpful. Thank you for watching, and I'll see you next time.